Hi guys, Patrick here from EngineeringShock.com and ElectronicLessons.com. Today I'm going to show you something that I don't normally do. I'm going to show you me doing an experiment. What I've got here is a beast of a transformer. It has secondary coils at 6 volts AC, 5 volts AC, and 400 volts AC. And the 400 volts AC are back there, and the leads are taped. They're taped because there's about 80 watts of potential there. 400 volts at 200 milliamps. If I short that across my chest, I'm likely pretty toast. That's much stronger. Even at 200 milliamps, yeah, that would toast me. So that's all taped off. What I've got here is a big mess of things. I've got the 6 volts AC output, not center tapped, connected to a huge rectifier with a nice big fat capacitor and a decoupling capacitor in the middle. It might be very hard to see. Hold on, let me zoom in on it and see if you can see it a little bit better. Yeah, there you go. It might be hard to see. I've got actually 8 diodes here. Each set of my bridge has a doubler in parallel, just because what I'm going to do with this requires a hell of a lot of current. Now, some of you engineers out there might be thinking thermal runaway, and that would be if I'm trying to take a lot of power from this transformer, that if I put diodes in parallel, that one might burn out and then the other might burn out. But in this case, I'm only going to be really saturating this transformer for seconds at a time. What I'm going to do is I'm going to charge big bulky supercapacitors. Now, normally supercapacitors, you have to limit the charge through a current limiting resistor because your wall transformer can't handle it. You don't want to, and everything seems to be fused. This transformer, though, while the 6 volts AC output is rated for, I think, 3 amps, it can probably do up to 10 amps non-instantaneous. So what I'm going to try to do is, if I was to charge the single 2.7 volt 400 farad capacitor in my supercapacitor charger kit, it would probably take a good 20 minutes, half an hour. So I'm going to see how long it takes to charge it using this beast. Now, I'm not going to be charging it to exactly 2.7 volts, but I'm going to show you exactly how much juice I get out of this after just charging it for a few seconds. So let's give it a try. So what I'm going to do is I'm going to check how much this is a new 400 farad capacitor. What I'm going to do is I'm going to check to see what the voltage is on it right now. 191 millivolts. So what I'm going to do is now I'm going to set it up for charge, and you're going to witness me charging this for just a couple seconds. I've got ground connected, I'm powered on. What I'm going to do is I'm just going to touch. I've got my safety glasses on. Not that I expect this is going to pop, because it won't. It's designed to take in as much current as possible. But let's touch it for 4 seconds. 4 seconds, roughly. And now let's have a quick look to see how much charge to do. Nice. More than 600 millivolts. Now you're thinking, 600 millivolts, that's crap. That means that I've charged this to about 1/4 of capacity with 4 seconds. 4 seconds. Let's do 5 seconds this time. Now, I can actually feel the vibration. I can feel the transformer. I can actually feel the energy from this when I touch this lead. So, 5 seconds. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. Again. 1.032 volts. So mathematically, I could charge this 400 farad supercapacitor in less than 25 seconds or less. 25 seconds or less. That is a ton of energy. A ton of energy. So let's just do it one more time. We'll do it for 7 seconds. And we'll be pushing the limits here because the solder on our rectifier might start to melt. 1, Mississippi 2, Mississippi 3, Mississippi 4, Mississippi 5, Mississippi 6, Mississippi 7, Mississippi. Hopefully you can see that. 1.54 volts. Yes, so we're well on the way. Each charge we're giving it about 500 millivolts. Last time we'll do it 10 seconds and then that'll be that. Oh wow, this is hot. This is hot. I can imagine that there's actually stress along this wire because of so much heat being dissipated. Because again, this is 9 volts. There's 9 volts coming off this transformer. But because I'm touching it, it's sinking that voltage down to the voltage on my capacitor, because this is sucking out more voltage than my power supply can handle. 10 seconds. 1, Mississippi 2, Mississippi 3, Mississippi 4, Mississippi 5, Mississippi 6, Mississippi 7, 8, Mississippi 9, Mississippi 10, Mississippi. And I can feel the heat. I gotta stop that. I can feel the heat. Oh yeah. Alright. I'm hoping you could see that. .2 volts. This is a 2.7 volt capacitor. Now, if I have a supercapacitor charger circuit, yeah, and if I had this bulky transformer as a power supply, I could charge it in no time. We're talking about a supercapacitor flashlight charged up in 25 to 30 seconds using this charger, and you can use it for well over an hour. This is an amazing. I've never charged a supercapacitor with this much instantaneous power. Anyway, I'm pretty excited about it. Let me just zoom out quickly. This transformer is a beast. Anyway, I'm glad you guys got to take part in that, because if the capacitor exploded, you know, I wanted you guys to see it too, and then you could probably laugh at my my lack of a capacitor. These capacitors are expensive. Anyway, thanks for watching, guys. I really hope you enjoyed it. I've never ever done anything like this before, so thanks again.